Welcome to the Astro. In this Python for Astronomy tutorial, you are going to learn that how to read and visualize fits spectra of a galaxy NGC 4414, and the spectra has been obtained from Hubble Space Telescope. Okay, so you can see I have designed some steps in which we are going to follow these steps to read and visualize the spectra. So step 1 is to download the FITS spectral data from this website, and then I will read FITS spectra file. Then after that I will extract FITS file information. After that I will extract FITS header information, and then I will extract flux and wavelength for final plotting and showing the spectra from Hubble Space Telescope. So let's do it step by step. Okay, so first I will download the FITS spectra. So I will click on that, and I will type here NGC 4414, and I will run the query. So it's resolving that galaxy, and here you can see that this is the galaxy, and if you go here you can see the spectra. So you can observe here that a spectra contains HST, LMOST, and other X-ray. So I will go for HST and click on the optical, and then here you can see that there are the spectra, and I will take the second one. Now I will download this spectra. So here it's downloading. You can observe that. Now I will open the folder and I will put this file into my Jupyter Notebook directory. So here I am extracting. So open it and go to the product. So here you can see that. So take this x61 file and extract it. And then you can copy this file to our directly corresponding to your Jupyter Notebook directory. Now, okay, so our spectra is in our directory. Now we'll go to our Jupyter Notebook and we'll read this FITS spectra. So for that I will use a library called Astropy. So import it. So from astropy.io import FITS. So this library deals with FITS file. Now I will read the file. So I will type here HST spectra, right, as a variable, and give here fits.open. So this will open your file, and then you can give okay. So this will open your file. Now, so this will read the file. Now we have read the file. So if you type here HST, you can give some information. Now I will extract FITS information. So for that, type here HST spectra dot info and give function. So now run it. So here you can see that it has two SDU, primary and science. So and So in your science SDU, there is a bin table SDU which contains the data, right? And it has dimension of this row and column. And okay, so now I will extract fits header information, okay, from this science SDU, right? So extract fits information. For that, type here HST Spectra 1 dot header, right, and run it. So here you can see that there's a lot of information regarding this fits file 06963, and you can see that it is a binary triple extension, 8-bit data, and it has a 2 axis, and this is a number of rows in a table. Then you can see it is here is the wavelength, and it has light dimension 24 length. You can see its unit is angstrom, and similarly you can see the flux is in the unit of this unit, and it has dimension of 24 length, and other things in that fits file. So for time being we have to use, and also like there's an array and deck of the position So but for time being we have to extract our wavelength and flux, so we have to use this keyword to extract. Okay, so I will use this keyword flux and then wavelength to extract my data. Okay, so I will go below, and now I will extract data. So for extracting data, type here data equal to HST Spectra, and here 1 for your science SDU, and type data. So I will write here 1. So here 1 for your 1 stands for your science SDU, right? Now we have read the data. You can print it. So this contains a lot of information, right? This contains a lot of information in that with number. Now we have to extract. Now we have to extract only its flux and wavelength. Okay, so I will extract. So extract wavelength, right? So for type here I will type wave, and I will type here data the square bracket, and in the string I will type here wavelength. So it's wavelength. Now you can check it. So this is your wavelength. Okay, and this is the row. Okay, this is the row. So it is in one. It is in rows format, right? So similarly you can also read your flux. So for flux type here HST data and flux. Okay, so you also got your flux. You can check it. Okay, you could check the shape in p dot shape. So you can see it's one rows, this much column. Okay, so we have to extract to the column values. So for that I will okay, now we have okay, so I will just simply print wave and flux. Okay, now we have to plot it. Okay, so for that I will import here, import numpy as np, and then I will import matplotlib matplotlib.pyplot as plt, and then I will plot it simply. So plt.plot, and I will pass my wave and flux, right? And I will type here plt.figure, and okay, so plt. Also show. Okay, so you can see that it's not showing, so I will put this data as a column. Okay, so for that I will put here as a row. So and same flux or flux also. Now here you can see that here you have the spectrum, okay, of the galaxy, and the unit is in this. Okay, so this way you can upload the spectrum. I have one more file, you can also plot for that file. So if I go here and change another file, now okay, so I will go for this file. Okay, so here is also a spectrum of another Fates spectra from HST. Okay, so you can also give some label, and you can see that the wavelength vary from 3000 below to 55 angstrom. So I will give a title here. So plt dot title, I'll put here HST spectra, and then I can give plt dot title equal to, you can see here wavelength lambda. So I put here LaTeX format and $$ backslash lambda, and there should be X level. So okay, so you got your lambda angstrom. Okay, and you can give unit as, so it's an angstrom unit, and then you can give plt dot y level as a this unit. So our flux unit is, you can observe from here, it is in this unit. So copy it and go to math mode, and you can give the unit as right plt dot. Okay, so this is the unit of our flux. Okay, can type here flux. So here you can see the spectrum. Okay, I will run the whole code once again. Okay, so I'm going to define here this PLT dot. Okay, so here's a spectra, right? So you got here lambda in your moving frame. This is the unit of the flux. So these are like the lines. If you observe, these are like lines, and these are like called emission lines, and these are the below deep is called absorption lines. Okay, so this is one spectra of HST, and one more I can plot here. Okay, so here it is. Now you can zoom this plot if you want. So plus add here percentage matplotlib widget, and you can see you got here some buttons. So you can zoom the portion if you want. See, you can see much zoom portion of your spectra, and suppose you want to go at this line, then you can check it. This is how your line looks like, the HST spectra. So I expect that this tutorial has been helpful to you to get some insight about HST spectra and how to plot it. Okay, so thank you. Let's see if it fits. Okay, so there's one more spectra. I have 2 files. So this also represents the another spectra of the HST data. So these are emission lines, these are the absorption lines. So thank you.